Hello everyone, and welcome to Jam Academy. In this example, we have a variable force. So I want to show you how to apply the work kinetic energy theorem when there is a variable force involved. Now, the work kinetic energy theorem essentially states that the net work done on a system is equal to the change in the kinetic energy of the system. In other words, the consequence of doing work on a system is either to change the position of the system or to change the speed or the kinetic energy of the system. Now, mathematically, it simply states that the total work done or the net work is equal to the change in the kinetic energy, which is Ke final minus Ke initial. So this is the work kinetic energy theorem. So the question says a force whose magnitude is given by F equal to Ax plus half Bx squared, where A and B are positive constants, is applied to a mass or to a box of 10 kilograms that is sitting on a horizontal frictionless surface of a polished bench. If the box is initially at rest at x equal to 0, what is the speed after it has traveled 5 meters per second? Now we know that the initial kinetic energy of the box is 0 because it is initially at rest at x equal to 0. Now we want to calculate the speed of the box at x equal to 5. So there are two things we need to do. The initial and the final point pretty much have been chosen for us. So we know that Ke initial is equal to 0, and we know that K final is just going to be equal to 1/2 mv squared, where v is what we are actually looking for. Now the next question really is for us to define the net force acting, the net work done on that particular box. But to calculate the net work, we need to calculate the net force. And to calculate the net force, we need to know the forces acting on the box. The best way for you to keep track of the forces acting on the box is for you to draw a free body diagram. Now, a free body diagram per se, really, it's a diagram that shows the forces acting on the object, not the forces exerted by the object. We have the weight, which is vertically downwards. We have the normal force, which is perpendicularly upwards, and we have the force F acting on the box. So from the look of things, we know that the sum of forces in the y direction is 0. That would mean that N is equal to mg. The good news is there is no friction, so there is no force acting in the opposite direction of motion. Now the sum of forces in the x direction is just going to be equal to F of x. And we know what f of x is. It's equal to ax plus 1/2 bx squared. This essentially is the net force acting on the block. So to calculate the net work, which is Wt, is going to be equal to the integral from 0 to x, because the initial position is x equal to 0, and the final position is x equal to 5. And this is going to be f of x cosine of theta dx. Now, remember, theta is the angle between the force and the direction of motion. In this case, it's equal to 0. So that means, that implies that we have from 0 to x, ax plus 1/2 bx squared dx. If we integrate this, we will have here ax squared over 2 plus 1 over 6 bx cubed. We're integrating from 0 to x. This would imply that W total will be equal to ax squared over 2 plus b over 6x cubed. This is the net work done on the block as a function of position x. All we now have to do is substitute the values. So we now have the net work equal to A is 2. So this is going to be 2 bracket x is 5 all squared divided by 2 plus b is 6 over 6, 5 raised to the power 3. So this will be equal to, this 2 takes care of this 2, 6 takes care of 6. So you will have 25 plus 125 joules, which essentially will be equal to 150 joules. So this is the net work done on the object. Now, all we have to do is apply the work kinetic energy theorem. That means that 150 joules is equal to 1/2 mv squared minus 0. In other words, 150 joules is equal to 1/2 m is 10 multiplied by v squared. So we can see that 5v squared will be equal to 150 joules. In other words, v squared is going to be equal to 30 joules, and v is equal to the square root of 30 meters per second. So this is the speed of the box at x equal to 5. Now, this is a very beautiful problem. If you have any questions regarding this problem, my proposition is participate in the discussion forum below this video, and we will be able to help you understand the concepts. Thank you so much. It is a privilege for me to bring you these lectures. Stay tuned and see you next time. Bye-bye.